To finish off section 8.4 and 8.3 content, we're going to look at some applications of determinants. So in the previous video, we kind of went from sort of the basic 2x2, we went to some pretty crazy notation, and then we came back to a 3x3. We're going to apply this now to a couple different examples. They're both going to deal with area, but there's going to be sort of two different situations here. So to start off with, I want to look at finding the area of a parallelogram in the coordinate plane. So let's just say that we have a parallelogram and it's in the xy plane here, x, y, and we'll say that, so this is 0, 0. I'm going to use 1, 2, 3, 1, and I'm going to use 2, 3, 4, negative 5. And then I'm going to need this. So here is my parallelogram, not quite drawn to scale. It actually almost looks like a rectangle, but remember, parallelograms are often sort of tilted rectangles, so it probably looks kind of like that. Now, in order to find the area of a parallelogram, it's the length of the base times this height here. Alternatively, if you're given the angle, it's sort of the length of this slanted part with the base and then times sine, so you could do a times b sine of theta, which would really just give you the height, so that's the same as b times the height. But in this situation, we're not really given that information. So what I'm going to do instead is make this a vector here, 3, 1. I'm going to make this a vector, 2, negative 5. So I have my two vectors u and v. U is the vector 3, 1, and v is the vector 2, negative 5. Now, we could use the formula to find that angle, so cosine of theta equals u dot v over the magnitude of u times the magnitude of v. This is from chapter 6 content, so we could find the angle, and then we could actually use the formula I've written above there to find the area of the parallelogram. However, this is a lot easier than that. So I'm going to create a matrix, I'll call it the area matrix, which is going to be 3, 1, and then 2, negative 5. So you'll notice this first part is really just u, and the second part is v. And then I'm going to find the determinant of this matrix. So it's going to be negative 15, so 3 times negative 5, and then minus 2 is negative 17. Area can't be negative though, so I'm going to take the absolute value of that. So the absolute value of negative 17 is positive 17. And actually that's the answer. So in order to find the area of a parallelogram, you really just set up the two vectors in a matrix and then take the determinant of that matrix, which is pretty straightforward. So that's pretty cool. The next application I want to cover deals with the area now of a triangle in the plane. So similar to the parallelogram, except now what I'm going to do is come up with some points for a triangle. So let's go ahead and do, let's see here. Let me get my example. So we're going to go with 1 and then negative 2. I'm going to go with 3, negative 4. And then we're going to go with 5, 2. So let me go ahead and label those points. This is the point 5, 2. Over here we have the point 3, negative 4. And then this is the triangle. And then this one over here is 1, negative 2. So as you probably recall, the area of a triangle is 1/2 the length of the base times the height. So we could actually do that. We could find the length of this base, and then we'd have to somehow figure out that height. Which is all, like I said, it's possible we could do that. But let's go ahead and use the determinant again to do this. So here's what I'm going to do. I'm going to create, once again, my area matrix. And I'm just going to put the points in here. Except the problem is this is not a square matrix, so I'm also going to make a column of just ones. So over here we have the points, the vertices of the triangle, and then this is just always going to be a column of ones. Now my goal is going to be to take the determinant of this matrix. So there's a lot of ways you can do it. You could go with what we talked about in the previous video, just use row 1. Although I actually prefer to use the column of ones. So I actually prefer, unless there's some zeros in column 1 or row 1, I prefer to use column 3 because those ones kind of make things a little bit easier. So we're going to use column 3, so that means I'm going to be looking at A13, which is 1, A23, which is 1, and then also A33, which is 1. So just kind of going down the row here, A13, first row, third column, then A23, second row, third column, and then A33. Now I need the minors. So I'm going to use, for minor 1, 3, I'm going to use this matrix. And then I'm going to use 2, 3. And then I'm going to use 3, 3. So 2, 3 is going to be 1, -2, 5, 2. 3, 3 is going to be 1, -2, and then 3, -4. Remember, the minors are eliminating rows and columns and then dealing with what's left. So this gives me 6 minus 20, so 6 plus 20 is 26. This one gives me 2 minus -10, so I actually get 12 here. And then this last one is -4 minus -6, so I end up with 2. And then the final step is to do C13, which is really the exact same thing as the minor, except it might be different by a negative. So I'll go ahead and just write these out. Okay, now we're going to multiply. So let's go back to the determinant I was trying to figure out. The determinant of A is going to be A11 times 26. And here's where those ones are nice, because 1 times 26 is just 26. 1 times -12 is just -12. And then 1 times 2 is just 2. So really it just turns into adding the cofactors rather than doing any multiplication. 26 minus 12 plus 2. So I end up with 16 here. Now this is almost done. This is actually the area of kind of the square that we could come up with that. We're going to still use part of the formula, which of this 1/2 base times height up here. We're going to use that 1/2 now. And so then the area is just going to be 1/2 times 16, which is 8. If we had a negative number, we would just change that to a positive. And so the final answer is this is B, 8 square units. So for the area of a parallelogram, we did the sort of the absolute value of the determinant of its area matrix. So this was a 2 by 2. And then for the area of a triangle, we did 1/2 times the determinant of that matrix, which was a 3 by 3. And technically, I do need absolute value of each of those. So just to remember, you're finding an area, so it should be the positive amount.